How's it going, everyone? In today's video, we're going to learn about typed dictionaries in detail. In the previous video, I briefly mentioned that they could be used to create structured types that represent your dictionaries accurately. So let's get started by creating a couple of regular dictionaries to see how using a typed dictionary can improve our code. To get started, I'm going to create a user called Bob. And right now, we're not using any type annotations. And just like this, the static type checker or Python can infer that this is a dictionary of type string, toString, or integer. String is the type of the key, and string or integer is the type of the values. To type this, we can just insert that annotation right here, and that would be the correct way to type this dictionary. Now, if we insert something such as a float, which is 10.5, we're going to get some syntax highlighting. And if you run your static type checker, you're going to get an error. And if this type becomes too complex, we can always create a type alias using the type keyword. So now instead of saying that Bob is of type dictionary, we can say that Bob is of type user, because this represents a user. And everything's going to work exactly as a dictionary should. As you can see, we can access name and age normally. But once again, this contains no structure. Here we can add as many items as we want to this dictionary, as long as the values are of type string or integer. So in reality, this dictionary could look like anything. We could even type in job and add chef and add a wage of 1000. Since we did not define a structure here, we can put anything we want inside here as long as it follows this type signature. Now, imagine you have a more complex dictionary. This is how your code editor or Python would see this type. And while it's accurate, it's still far too broad of a type annotation because the values can be of any of these types. And the dictionary, once again, can contain as many items as it wants. There is no structure here. Of course, we can type in type user equals this type and specify this user to be of type user, but we can change any of these fields as long as we follow this type. So name can be job, once again, and we can insert chef here. We are not required to add a key named name. And if we're expecting that, this can easily ruin our script. And this is where typed dictionaries come in. To use a typed dictionary, we import it from the typing module. And to create a typed dictionary, it's going to be very similar to creating a data class. So here we can type in class of type user, or a class named user, which will inherit from typed dictionary. And then we just define the fields: name of type string, age of type integer. Here we're telling the static type checker that this dictionary type must contain the keys name and age, and that they must be of these types. Which means if we create a user called Bob, we must include those keys and those values. Otherwise, if we insert something different, such as 10.5, which is a float, the code editor or the static type checker is not going to be happy. And if we exclude one of these values, the static type checker won't be happy either. This is the structure of the dictionary. We must follow that. And we cannot add new values. We can't say job will equal chef. This is not something we specified in this type, so it's not allowed there. And for those of you who are new to the world of typing in Python, you need to know that all of the warnings are only for the developer. We can still run this code with no issues. The point of these warnings is so that we can fix the code before we run it, since by nature, Python doesn't care about anything if you do not use typing. As you can see here, we have no warnings for Bob because Python has no idea what we were trying to do here, other than that we wanted to create a dictionary. With the type annotation, we tell Python specifically what we want to do here. And that's good because if we make a mistake, we can catch that. Now, going back to the bigger dictionary, let's see how we can type this using a typed dictionary. And I'm going to do this from scratch so you can follow along. To get started, we'll create a class called user that inherits from typed dictionary. And the first three fields are going to be name, age, and emails. So it should follow this structure precisely. Now for the address, since we have a nested dictionary, we're going to create a nested type dictionary. So right below this, we're going to create an address of type address. But obviously we did not create an address just yet, so we need to do that. And right above, we can create this address, which also inherits from typed dictionary. And the address needs to contain all of these key value pairs. So we need to insert a street, a city, a postal code, a country, a latitude, and a longitude. And that's something you have to type out by hand. And just remember that the keys here are case sensitive and should match the keys found in the dictionary. If we add an uppercase P here, first of all, my syntax highlighting is going to make it look like a class, which really isn't important. But what is important is that as soon as we try to use this type annotation on this user, it's not going to recognize the postal code because it's expecting a postal code with an uppercase P. So make sure the keys match the dictionary exactly. But with this being done, we can still use the dictionary as normal. We can type in print user at the index of name and the user at the index of address and city. So we can find out where Bob is from. And when we run this, we will find out that Bob is now from Auckland in this universe. So that's quite nice because now we have a structure, an actual structure that our dictionary needs to follow. But up next, I want to show you how you can make certain fields optional. And to do that, we're going to take a step back and create something simple, such as a user which contains a name, an age, and an email. Now, if we want to tell Python that we want dictionaries to follow this structure, but that none of the fields are required, we can do so by providing an optional argument called total and setting that to false. With this being done, we can now create a dictionary, which will be a user of type user, and it can be empty, or it can contain a single name, which will be set to Bob. And this is fine because all of the fields are optional. If we want, we can also include an age, which will be set to 34, and that's fine as well. We are not required to pass in any of these fields, but these are the only fields that we can use. So we cannot invent something such as a job and say that Bob is a chef. We cannot do that because we did not define that in the typed dictionary. And personally, I find that total takes away too much from the typed dictionary. So I don't really use it that often. But there are some other types that are far more useful if you want to be more specific about which fields should be optional. Starting off with the required type. If we want to make sure that a certain field is being used, we have to mark it as required. And this shouldn't equal required, but should be of type required, which will contain a string. And that's something we need to import from typing as well. Now, once again, total marks all the fields as optional. So in combination with required, it works quite well because now we're telling Python that these two fields are optional and that the email is required. So if we want, we can pass in an email and set it to bob@bmail.com, and Python will be happy. We can also exclude the name and the age, and this will still work. But we cannot exclude the email because we marked it as required. And funny enough, we can also do this the other way around by importing not required. Now here I'm going to remove the total arguments and set this to not required. So now email is the only field which is not required. It is optional, which means we must include name and age, but we are not required to include an email. I mean, watch what happens if we include an email and exclude the name and age. This time we'll just add b@bmail.com, and you'll notice that we're going to get that syntax highlighting because name is required and age is required. But if we do this the other way around, it's totally fine because the email is not required. And you can also mix these up if you want. You can specify that the name is required and that the age and email are not required. You can use these together. Personally, I would set total to false and only mark the required fields, because otherwise I find this to be quite hard to read. Or not really hard to read, but it just clutters the screen a lot. So in my opinion, this is much better. And right now we're getting some syntax highlighting because this should be of type string. So the name is required, but the age and the email are not. Although I think it makes more sense to keep it on the email and make the name optional. And there's one last feature I want to talk about, which was introduced in Python 3.13, and that is the read-only type. And to use it, we can create an ID of type integer, or it should be of type read-only, which will contain an integer. This will mark this field as read-only, which means if we were to create a user and try to change the user's ID to something such as 10, we would get some syntax highlighting because ID is a read-only key. And right now this is unhappy because I did not include an email. So we'll pass that in. And this time we'll type in bobby@bmail.com. Now the static type checker is not going to complain anymore because we passed in the required field. But right below, it will complain because we're trying to change a read-only value. And one more time, I want to stress that all of these warnings do not affect our code. We can still change the ID, but it's quite nice that we get a warning. Because now when we read through our code, we'll know exactly where the bug is located in our code. Since this is an operation that shouldn't be possible. Or not that it shouldn't be possible, but it's something we do not want to do because it will break our code. So yeah, that's actually all I wanted to cover in today's video. Do let me know in the comment section down below what you think about all this, whether you use typed dictionaries or whether you have some extra tips or tricks that could be quite useful when you're using a typed dictionary. I would love to hear about all that in the comment section down below. But otherwise, as always, thanks for watching and I'll see you in the next video.